Dear colleagues, dear friends, and students, welcome back to another episode of our new development tool, which we are making for hobbyists and electronics students and others who are interested in programming and embedded systems. In this series of what you can say uh, tutorials, we have developed a system to learn and to program in a fun way. Before that, usually we used to program on the development boards like Arduino boards and our other boards, and which had a number of peripherals on it, and we could experiment with those things like how to use the buttons, how to use the display, and etc. This time we have made a different effort in which we have developed a gaming console, and you can use it not only for gaming console but as a general purpose development board as well. However, it will be more fun using it as a gaming console so that you can experiment with your ideas to develop the games and things like that. And by the way, games are a wonderful medium to develop, design the programming strategy, algorithms, and a lot of other structures, etc., so that you can play with the variables and resources of the microcontroller, especially when you have a limited memory and things like that. So games are a very good way of challenging your brain to develop the necessary skills. So we have developed this board, and along with that, we have also developed a framework, which is actually an Arduino library that you can use to leverage the game development cycle and game development process to isolate you from the hardware details or to abstract away these hardware details, and so that you can concentrate more on the logic and game development rather than uh, struggling with the low level hardware controls. So let's first have a brief look on the entire ecosystem which we are going to develop, and gradually we'll show you uh, how we proceed. So we have named this project as NanoBoy because it is based upon Arduino Nano, and this is an Arduino gaming console, both hardware as well as software. You can experiment with it. This is an open source. You can develop your own things. It's very easy, or you can even experiment with the simulators. In early days, there was a company named Nintendo. It is still there, and it had developed a Game Boy, which was a very popular pocket-sized device in which there were a number of games, and you could use this D-type uh, control and two buttons A and B, and these two buttons for selection of the things. It had a single monochrome display, and there was a speaker in it, and all the games were already built into it so that you can select which game you want to play. So we are not developing for to play or entertainment, because we are developing a platform where you can write your own games, and even the community can develop the games and share among each other based upon this platform, so that we can together learn how to program the games. So there is another very popular device which is available on the internet, and it's also open source, which is called ArduBoy. This is also based upon Arduino, and it is based upon ATmega 3 to 32 microcontroller, not 328, based upon ATmega 32U, which has a built-in USB port, and a number of games which are available for this Game Boy have been ported to for this particular hardware, which are available on internet. You can just download and uh, upload to this controller and play it. But most of the games which I have seen, they are all hex files, and you can just use them and play with them, but not the source files, so that you can see what's happening inside. So uh, to me, the more important thing is that we should be able to program the source codes so that we can learn it. Then there is an homemade Arduino projects in which the same structure, same hardware which is on this device, and here it is the OLED display and four buttons, a buzzer, and an amplifier, and two of these buttons A and B, and few LEDs for to indicate various things are there. So we have developed NanoBoy. So NanoBoy is basically based upon ATmega 328, which is present on your Arduino Uno, Arduino Nano, which are very commonly used and commonly available. Indeed, many people have these in their toolboxes, so it will be very easy to make them. The hardware is not actually yet ready, so I will be demonstrating it on the simulator, but it will be available shortly. This is the basic schematic of our Nano, in which this is the Arduino Nano or microcontroller. Basically, it has this OLED display, which is connected to SDA and SCL lines of the microcontroller, which are I2C lines. One LED, which is connected to D8 pin, and one speaker, which is connected to D9 pin. Then there are 6 buttons. 4 are arranged in the D-type fashion, up, down, left, and right. And these are connected to D2, D3, D4, and D5. And then there are buttons A and B, which are connected to D6 and D7. That's it. That is the only hardware which is present. This built-in LED which is connected to D13 is part of the Arduino Nano. So you have basically two LEDs on the system. One is part of the Arduino Nano and the other is part of the our game console. So it is based upon Arduino Nano, which is ATmega 328. It has 6 push buttons, an OLED display, which is SST1306, a buzzer, and a status LED. And we encourage you to learn C++ programming with Arduino in a fun way. So the hardware connections, these are fixed connections. The SSD or 1306 OLED display is connected to SDA and SCL lines, which are A4 and A5 pins. And then there are push buttons, up, down, left, right, connected to digital pins 2, 3, 4, and 5. Button A is to 6, button B is to 7, LED to digital 8, and buzzer to digital 9 pin. All other pins which are present on the Arduino board, they will be available as headers for your extension to other sensors and other devices if you want to connect, so that this will be available as a free header. So the heart of this device is this OLED display, which is very good. It has a resolution of 128 by 64 pixels, so 128 pixels like this and 64 pixels in the y-axis. This is a monochrome display. It does not need a backlight, so it is very much energy efficient, and it has a very good contrast ratio, and it works on I2C communication, so it basically needs only 2 lines, SCL and SDA, and one is power and ground. That's it. The beautiful thing is that the Arduino has a number of libraries already available for these devices. So we will be using those libraries on top of the along with our library to make it work. So software, you can use any software with which you can program AVR microcontrollers like Microchip Studio, Visual Studio Code with Platform IO, or even simple Arduino, which is a very popular development environment, and many libraries are freely available. so it will be good. So the gaming framework, which we will be discussing later, because this framework is only developed by us and it is available from this our GitHub repository. We will mention it um, in the description, and you can download it. It contains a number of functions to develop the games because it abstracts away many hardware details and gives the concepts of function like sprites and animations and collisions and or etc. All these things are detected automatically by this library. Remember, this library depends upon this Adafruit library, so you will have to install those libraries first. So let's move on to the system. First of all, you will need to download the library. Let me show you first that let's start with a brand new setup in which I have set up a folder named games. So this folder is empty, all empty. There is nothing in it. So when you start the Arduino, and you go to the files and preferences, you set here the sketchbook location as d:\games because it is important to have a specific folder where you will place your own code and where you will download your own libraries. Remember, there are two types of libraries which are available in Arduino. One are the libraries which come pre-installed with the Arduino IDE. These are part of the core libraries and these are already installed, like Liquid Crystal library, like Servo Motor library, like USART library. These are all pre-installed libraries and they are present in the with the core of the Arduino. But when you download the third-party libraries like Adafruit libraries or like graphic libraries or some other libraries from the library manager, those libraries get installed into your this folder. So if you change the folder, those libraries will remain installed in that folder only. So if you change the folder, you will have to download those libraries again. So let's say we go to this folder and start. So here is the folder structure. If you come here, there is no sketchbook, nothing here. And if you go to the tools and libraries, and you can see there is no libraries are installed into this thing. And since we have not selected any board, so first select the board and we can select the Arduino Nano. And now the board specific libraries are already appearing, which are all those libraries which are part of the Arduino ecosystem. There is no downloaded libraries. And as you can see in this folder, the games folder, let's open it. This folder is all empty. So let's first import Adafruit libraries. So we go here and we say Adafruit SSD 1306. This is the library for display SSD 1306 OLED driver library. So we install it. So when we install it, it says that this library is dependent upon Adafruit Bus IO library and Adafruit GFX library, which are also important for our libraries. So we install all. So these libraries are installed. So if you now go to the folder, games folder, you see another folder has been created, which is called libraries. So this folder is local folder in this folder. And this libraries folder has these libraries which have been downloaded from the internet. So if you change this folder for your applications, these libraries will remain part of the games folder and you will have to again download them. Right. So if now I go to the sketch and include libraries, so in addition to these libraries which were part of the Arduino, now there are contributed libraries like Adafruit Bus IO, Adafruit GFX, and Adafruit SSD 1306 libraries. Right. Now we want to download our library, which is NanoBoy library. So for that, you go to our GitHub page, this github.com/AmirIqbalQureshi/NanoBoy. And on this page, you can just view the details of the library, and you can download it from here and download as zip file. So this is downloaded. Okay, nanoboy-main.zip. Most of the time when you download a library from GitHub, that library itself is extracted, and you can just uh, copy it into your Arduino. But this library is actually uh, compiled with other data. So let's go to downloads, and this is the library. Let's copy it. Control C, and I paste it on the desktop. Right here it is. So first of all, we extract it. We don't use the zip file. We extract it, and by the same name. Right. So here it is extracted. This is. So you can see here there is a NanoBoy main folder, and in it there is a NanoBoy zip file. This is the actual library which you will need, and along with that there are two documentations, and a Proteus simulation is also present in this folder, which you can use with Proteus 8.13 version to simulate the game and the programming if you need so. So let's install this library. So we have extracted it, and you don't have to extract this, let it remain zipped file. So let's go to the Arduino, sketch, include library, add dot zip library, and then we navigate to our folder, NanoBoy main, and this is the NanoBoy zip library, and successfully installed library from NanoBoy zip. And if you go to the include libraries, now you can see the NanoBoy library is available. You can use this library. And also in the examples, you will find the NanoBoy examples, and these are the various example programs which are available in it. So now how to test it? Either you get our NanoBoy hardware, which will be shortly available from our partner companies like Digilog, or you can order it directly from us, or you can check it with our this Proteus simulator. So just run the Proteus 8.13. Most of the people have this software, and we open project, and on desktop we had installed it. Desktop, NanoBoy main, and this is Game Boy. We open it. Right. So here is the microcontroller. Here is the OLED display. These are the four buttons, two buttons, and the speaker, and these are just connection details. So now how to run the program? Let's see. We take an example. File, examples, NanoBoy, and let's say we take an example of Pong. So this opens in a new window, and you can see here we included the library #include nanoboy.h. That's it. You have to include only this library. All other libraries will be automatically included by this. You can just save it on your folder in the games folder, and we call it Pong. Let it. Now let's test it. We can just compile it, and you can see it compiled successfully. So normally you will connect the Arduino board and with it and just write the programming, upload here, and it will be uploaded. But now since I want to run it on the simulator, so I need to make the hex file. So the easiest way is to go to the sketch and click here, export compiled binary. It will be compiled and done. Now, if you go to the folder, games folder, um, the games folder, here is a folder named Pong in which our program has been saved, and it has another folder which is called build. This build folder has this pong.hex file, which is available for uh, use in the simulator. So let's load it into the simulator. Let's come here, we double click it, and program file is loaded from here, and from here you select the D colon games Pong build Arduino AVR Nano and this Pong hex. So it has been just compiled at 8:56 and time here is 8:57, right? So you select this hex file and OK and OK, and now you run it, and you can see it is running here. It will also be producing sound. See, this is how you can play the games with this simulator, and you can develop various games with this library. And there are a number of possibilities which you can do with this board to learn program in a fun way. And if you look at the documentation which we have provided as such, so this is a simplified version of NanoBoy reference library, and here are the various commands like nanoboy.begin, nanoboy.clear, nanoboy.display, drawing primitives, text functions, sprites, maps, collision detection, input, sound, etc., etc. All these functions are available with this library. So we will be shortly writing few uh, coaching videos as well write a small booklet which will be helping you to use this library to develop games. And if you look at the code, let's look at the code. So you can see this is a small code, only 142 lines, and the idea of this loop is all the game is handled here. Handle input, update game, draw game, and just delay. You can change it. And here are the different functions: draw game, handle inputs, collection. You can check the bouncing ball, and etc. etc. So various commands which you are present these are the commands. Some are C++ commands, while some are library commands. Like this nb dot button pressed is a command from the library. Similarly, you can see mm, uh, this nb.beep command. This is from the library. Then is nb.clear, nb.draw rectangle, etc., etc. These are various commands which are present in the library. So I hope you will enjoy working with this library and develop your own games and share those games with friends and community to help learn programming and just game development for a fun. And not only for game development, you can use this hardware or structure for other developments, like you can connect your analog devices or sensors to the various pins which we have exposed on the board, actually, um, which are unused by these things. And you can also reprogram the buttons for other jobs, like for making a menu or like making some other things. So hopefully you will enjoy. Thank you very much. Stay connected and do give us a feedback, how we can improve it and how further we can help. Thank you very much.